Okay, let's look at number 4. You must prepare a 250 milliliter solution of dextrose 6% in water using sterile water for injection, dextrose 10% in water, or dextrose 50% in water. How much of which two will you need? So we know that sterile water is going to have to be one of them. We need to figure out which dextrose we want. We'll go ahead and just do the 50. Looking at our desired percentage, it's going to be 6, so we know that's going to go in the middle. Keep in mind that sterile water for injection is always going to be 0%. So you're always going to represent that as 0. Since it's the lowest, it's going to go on the bottom. And we're going to go ahead and use the 50. So setting that up, 50 minus 6 is 44. And we know that that's going to be of the sterile water for injection. And 6 minus 0 is 6 ml. And that's of the dextrose 50, because they just go across. Okay, now remember we have to add the two together to get our total amount. 6 plus 44 gives us 50 ml. So now we're ready to set up our proportions. So let's just go ahead and do the dextrose 50 first. We're wanting to find out how much we need, how much volume we need. Remember, our final amount is 250 ml over 6 ml dextrose 50, and we're going to divide that by our total volume, which is 50 ml. Okay, so now we're ready to solve for x. So multiply it by 250. And x is going to equal 30 ml of the dextrose 50 in water. So we have our first one solved. Now we need to do our proportion to find out how much sterile water for injection we're going to use. So we'll set that proportion up. X is what we're solving for in milliliters over our final desired amount over the 44 ml of sterile water for injection, and we're going to divide that by the total amount, which is 50, just like we did on the top. Okay, so now we have our proportions set up, and we're going to go ahead and solve for x again. And multiply 250 times 44, divide it by 50, and x is going to equal 220 ml of sterile water for injection. Always make sure you include that so they know which one you're referring to. And then if we look, 220 plus 30 is 250 ml, which is our final amount. Okay. So let's do one more of these and then move on to the other method that we'll look at. Let's look at number 6. Prepare 250 ml of 8% dextrose from dextrose 5% in water and dextrose 20% in water. How much of each is needed? Okay, so setting up our box, we know that the desired concentration is 8%, and the two percentages they're giving us to work with are dextrose 5 and dextrose 20. 20 is the bigger number, so it's always going to go on top. So we're going to take 20 minus 8, and that gives us 12 ml, and then 8 minus 5, and that gives us 3 ml. So carrying that across, so 3 ml of dextrose 20 in water, carrying that across, 12 ml of dextrose 5 in water. Don't forget to add these two together. It's going to come to 15 ml total. And now we're ready to set up our proportions. So we'll do the dextrose 20 first. So we're solving for how much volume we're going to need of it. The final amount is going to be 250. We're using 3 ml of that particular strength. And the final amount is 15 ml. That's the total. So now we're ready to solve for x. And x is going to equal 50 ml. Okay, so now we know dextrose, 20% in water, we need 50 ml of it. Okay, but we're not done. We still need to find out how much of the dextrose 5 we're going to use. So we're ready to set that proportion up. Still solving for volume. The final volume amount is still going to be 250 over the 12 ml of the dextrose 5 that we're using, divided by the total amount, which was 15 ml. And again, we're ready to solve for x. These two are going to cancel out. 250 times 12 divided by 15, and x is going to equal 200 milliliters of dextrose 5% in water. Again, if you look, 200 plus 50 is going to come to our final amount, 250 ml. Okay, now let's look at the other method. If you turn to page 215 in our book, we're going to look at the alligation medial method. And this is going to be when we're finding the percent in the middle. So for the last problem, they gave us 8%. That would be what we were trying to find. So let's look at example 8.3.4. You've been asked to prepare a mixture with the following ingredients: 30 grams of 1% hydrocortisone, 20 grams of 0.5% hydrocortisone, and a 10 gram eucerin cream base. What will be the percentage of hydrocortisone in the final mixture? Okay, so we're trying to find what the final outcome of the percentage is going to be. So we're going to begin by determining the amount of the active ingredient in each of the items in the mixture. So we'll start with the 30 grams of the 1% weight and weight hydrocortisone cream. So we're just going to set up our proportion, and it's weight and weight, so it's going to be grams and grams. So we're trying to find how many grams. The final amount is going to be 30, and then it's going to be 1 gram over 100 grams because it's 1%. Now we're ready to solve for x. 30 divided by 100, and x is going to be 0.3 grams of hydrocortisone. Okay, so that was for that one. Now we need to solve for this one. So same thing, we're going to set up the proportion again. So we're trying to find how many grams over 20 grams, and it's 0.5%, so it's going to be 0.5 grams over 100, and we're ready to solve for x. $20 times 0.5 divided by 100 is going to be 0.1 grams of hydrocortisone. Okay, so now we know how many grams in each we need. Now it's time to use the proportion that the book is going to give us to find the final concentration. So what we're going to do is we're going to add the two together, 0.3 grams plus 0.1 grams. We're going to divide that by the final concentration, or I'm sorry, the amount of the mixture. 10 grams plus 20 grams plus 30 grams is 60 grams. Divide these, add these two, divide that, and multiply it by 100. And if you do that, it's going to come out to 0.6666 and we're going to round that to 0.7%. Okay, so let's look at a couple of the practice problems using the ratio proportion method and then using the proportion that they give us to solve for the final percentage